Section B4 of the exam, using the data from B1, calculate the CP and CPK values 4 points each. Although the process needs to be in control to calculate CP and CPK because you want predictability, calculate them anyway. Use 2 decimal places for CP and CPK values. Again, 2 decimal places. And also notice that I give you the standard deviation of 1.68. You do not need to calculate that. And the formulas are on the last page, which are these formulas. So to calculate CP and CPK, we're going to need some values from B1. So let's go ahead and start with X bar bar. We know to be 242.4. Got it. Standard deviation was given in B4 as 1.68. For the specification limits, they are located in B1. Here they are. Engineering specification limits, not control limits. Not control limits. Specification limits are 249. Lower specification limit is 237. And now we have all the information we need. Now, I do want to point out that some people are tempted to use the proposed specification limits at the end of this exam. Do not use those because they're proposed. They're not official. Proposed are a bit like this. You're driving down the road, the speed limit says 55. You decide, you propose to the state that the speed limit should be 65. It doesn't mean that you can automatically go 65 as soon as you make that proposal. You have to wait till it's approved, if it does get approved. Now that we have the necessary information from here, I'm just going to go ahead and delete this from our example so that I can bring the formulas with the numbers closer together. Let's go ahead and do our CP calculation first. We'll say the upper specification limit, which we said was 249, and we're going to subtract the lower specification limit of 237 by 6 times our standard deviation, which we said was 1.68. And it says our CP value is 3.36. Do not say 3.4 because it needs to be to 2 decimal places. So there's our CP value. CPK lower is going to be equal to X bar bar, which is 242.4. Minus our lower specification limit, which is right there, 237, divided by 3 times our standard deviation of 1.68. And that gives us a CPK lower of 3.024. Oh, that's too many. Let's back it up to there, 3.02. But wait a minute, we have a CPK upper. Let's calculate that. CPKU equal to my upper specification limit, which is 249, minus my X bar bar, which is 242.4, divided by 3 times my standard deviation, 1.68. And I fix that, 3.70. And so you say, well, which one do I use? You always use the lower of the 2 numbers. On this diagram, I'll explain the why of it. Is, let's just say the upper spec limit here, lower spec limit is here, and this is actually our process based on these 2 numbers. Now, then it's not quite right, but for illustrative purposes, it's good enough. Is we are really saying the problem is on the lower spec limit side which is this distance from here to here. That's closer than the distance from here to here. So you go with the lower number, which is 3.02. So there is your answer for CPK. Again, 2 decimal places. I do want to point out, like I did in the lecture videos, is that it's possible for your CPK to be negative, never your CP. It's possible for your CPK to be negative if this point here is either down here or there, if the average is above this or below this. But most of the time that's not the case, because if that was the case, you would have some real problems in your manufacturing process.